All right, welcome back, everyone. Today we're going to talk about simplifying expressions. In this section, you're going to learn how to identify terms and like and unlike terms, how to identify coefficients, how to combine like terms, and then how to use all of this to simplify expressions. So a term is just a product of a number and a variable. So these are things that you see all throughout problems in algebra. And so here I just wrote some examples: negative y, 2x cubed, negative 5, 3x z cubed, 2 over y, 0.8 z. All of these things are just terms. You would see them added or subtracted within a problem. Okay? Each term has a corresponding coefficient, and that coefficient is just the numerical part of the term, the number that's in front. Right? So if negative y is the term, then the coefficient is just negative 1. If 2x cubed is the term, then the coefficient is just 2. It's just the number in front of the term. It's the numerical part of the term. So now we want to identify the coefficient of each one of these. Well, the coefficient of negative 3y is just negative 3. It's the numerical part of the problem. The coefficient of negative x, if we don't see a number, it's understood to be 1, and so the coefficient is just negative 1. Now in part C, this is just a little bit harder, but this could easily be written as 1 over 7 times x, and from there you can see that the coefficient should be just 1 over 7, the numerical part of that term. So like terms are those that have the same variables raised to the same exponents. The coefficients don't need to be the same, just the variables and the exponents. Unlike terms are those that do not have the same variables raised to the same exponents. So we first need to be able to identify whether things are like or unlike terms. Here we have 2x and 3x squared. Well, they have the same variable, but they're raised to different exponents. And so these are unlike terms. Have to have the same variables raised to the same exponents. The second one we have 4x squared y, x squared y, and minus 2x squared y. They all have the same variables, the same exponents, and so those are all like terms. We could add all of those together. Finally, we have negative 2yz and negative 3z times y. We have the same variables raised to the same exponents. Remember from the last section that order of multiplication doesn't matter. So we can rewrite these in a different order. That part doesn't matter. All that matters is that we have the same variables raised to the same exponents. So y to the first, z to the first. Y to the first, z to the first. So these two are like terms. Terms can only be combined if they're like terms. And in order to combine like terms, we're just going to add the coefficients. The variables are going to stay the same. Same variables, same exponents. The only thing you're doing is adding or subtracting the coefficients. So now we want to combine the like terms in these different expressions. 7x minus 3x. Well, they both have x to the first power. So they're both like terms. So we can combine them. And we combine them by just dealing with the coefficients. So 7 minus 3 is 4. And so what we get is 4x. Remember, the variables remain unchanged. We're only adding or subtracting the coefficients. Now in the next example, we have 9n squared and 5n squared, or minus 5n squared. Those two are like terms, but this 3 is not. The 3 is not a like term. So we can combine the first two 9n squared minus 5n squared. Well, 9 minus 5 is 4, and the variables remain unchanged, so 4n squared. But there's nothing we can do with plus 3 except to just leave it at the end. There are no like terms to combine it with. For the next example, 2x and 3x, those are both like terms. 5 and 2 are both like terms. And so we can combine both of those. 2x plus 3x is 5x. 5 plus 2 is 7. And finally, we have 4y and 3y squared. Those are not like terms. And so there's nothing we can combine. We just have to keep it as it is. So when we're dealing with expressions with parentheses, and you'll see this a lot in later sections, the sign that's in front of the parentheses will distribute to each number within. Okay, so think about if there's a sign directly in front of a parentheses, think about it as a plus 1 or a minus 1, depending on what sign it is. So a positive would just mean positive 1, and that would distribute to both terms, and nothing changes, 3a plus 2. A negative would just imply a negative 1, and that would distribute to both terms, and then both of the signs change. So remember what happens when there's a minus in front. Those signs are going to change within that parentheses. That minus sign distributes. It is a very easy mistake to make, and most often people will distribute the minus sign to the first term and forget about the second one. It distributes throughout the entire parentheses. So let's practice this. We want to simplify this expression. We have 8 minus 7x plus 2. Well, we can treat that minus sign and just rewrite it as 8 plus negative 1 times 7x plus 2. Well, negative 1 will distribute. We'll get 8 minus 7x minus 2. And now we just want to combine our like terms. 8 minus 2 is 6. And then we just keep minus 7x. We'll do the same thing here on the bottom. Negative 2 times 4x plus 7. We can rewrite this as plus negative 1 times 3x minus 1. We're just replacing that minus sign with a negative 1. Distribute. Negative 2 times 4x is negative 8x. Negative 2 times 7 is negative 14. Negative 1 times 3x is negative 3x. And negative 1 times negative 1 is positive 1. Now we need to combine our like terms. We have two terms with x's in them. Negative 8 plus negative 3. They have the same sign, so we add the numbers. 8 plus 3 is 11. Keep the sign. And we need to keep the variable. And then we just add what's left over. Negative 14 plus 1 is negative 13. So we've practiced writing algebraic expressions from words, and this can be really important to problem solving. And so we're going to use the properties from the last few sections and our ability to simplify expressions, and we're going to extend this into writing out more complex statements from words. So let's practice this. We want to write each phrase as an algebraic expression. 5 plus the sum of a number and 1. Well, here, the 5 plus part is pretty straightforward. Here we have the sum of a number and 1. So the sum of a number and 1 is x plus 1. And so it's 5 plus x plus 1. And well, we know we can reorder those, or we could just think about it like combining like terms. 5 plus 1 is 6, and so we get 6 plus x. Now in the bottom part, we've got 4 times the sum of a number and 3. So the sum of a number and 3. And so 4 times the sum of a number and 3. Now we can distribute the 4. 4 times x is 4x, and 4 times 3 is 12. And so at the end of this lesson, you should be able to find the coefficient of a term, determine like and unlike terms, combine like terms, and write algebraic expressions from words and simplify.